All right, welcome everybody. This is going to be a class on the properties of electricity. Um, I just want to go over some vocabulary here first to start everything off. Amperage. And so you're okay. So your objective here is to learn more about electrical energy. Okay. And we're going to do some calculations, right? Because everything is made. You will analyze data. The objective, you will analyze data to describe the properties of electrical energy and become familiar with the equations used to find current, resistance, and voltage when 2 out of the 3 are known. Okay, amperage. It's the size of an electric current, right? How big the electrical current is, right? It will express as amps or amperes. If y'all have a coffee maker in your house, that runs on about 5 to 8 amps of power. Your electric oven, if you have an electric oven, electric stove, that's about 10 to 50 amps, depending on the make and features. The Chromebook that you're all using right now is between 0.5 and 2 amps, right? So your Chromebooks have not drawn, it's not drawing very much electrical current. A coulomb, this is a fancy word for the way to use to measure electric charge, right? And it's represented by the unit C, right? International Symbol System of Units. All right. Dimitri, would you mind reading this this slide for me, please?
Give me a minute and grab my glasses.
Okay.
An electrical current, a path or a line through which electrical energy flows.
This is not current. This is circuit.
Oh, circuit. Sorry.
All right. So
We were talking about current, so current stayed in my mind, and my mind's like, it's current. It's current.
right. So battery
Circuits. Sorry.
goes to the switch, goes to the light bulb, all connected by wires, right?
Also, when you turn on the lights, that's making a current, right?
It's when you turn on the light, you're using current. You're not necessarily making current.
I knew it's something that has to do with currents, but it's when you're turning on and turning off lights.
Okay. So a joule, it's a unit of energy used to measure the energy and the work, and that's represented by international system. Back. J, right? So if we want to get technical here, it's equated to 1 Newton meter or 1 watt second, right? 100 watts equals 100 joules per second. All right, Jasper, can you read this slide for me, please?
Potential energy. The energy stored by an object because of its possession relative to another object.
All right, so we have a boulder at the top of a cliff, right? It's got a lot of potential energy because it's very high up. Or if you compress a spring, right? You compress a spring. It's got a lot of potential energy, right? We have the yield ink pen's got a spring inside of it, right? I'm compressing the spring and it releases, okay? Power. The amount of work done over a period of time. It's basically the rate of energy transfer or the rate at which work is done. So you have watts, kilowatts, megawatts, gigawatts, terawatts, horsepower, BTUs, British thermal units, joules per second, foot pounds, right? So power is measured, and so somebody, just Sean, can you read this slide for me, please?
Mills in Westing,
Watts, it's pronounced watts.
okay, watts,
Kilowatts,
kilowatts,
megawatts,
megawatts, horsepower, Bristol thermal
units,
units per hour, BTU,
all right? So,
also second,
and joules per second.
joules per second.
So light bulbs, right? We all have light bulbs in our house, right? 60, 55, and 100 watts, right? The 55-inch TV that y'all might have runs at about 116 watts. If you have an air fryer, or mom has an air fryer, dad has an air fryer, that runs at 1500 watts. An electric stove has 2.6. This is the abbreviation for kilowatts right here, kilowatts, right? And you go out camping, you take a little generator out with you. A portable generator might produce anywhere from like 1,000 watts, 1 kilowatt, to the example that I snagged was, it produces between 9.5 and 12.5 kilowatts, right? An electric space heater would use British thermal units, especially if it's run on gas or propane, right? Cars, trucks, the big trucks, the big rigs, right? They have horsepower. Dimitri, what's your favorite sports car?
A Camaro.
Camaro. Camaro has horsepower of a Camaro. 2024 Chevy Camaro, 335 to 650 horsepower, right? That means, how much power the engine produces, right? And a horse-drawn carriage is literally a 1 horsepower vehicle. Yes, Dimitri?
I just wanted to say, for horse-powered carriages, you'll mostly find those in Louisiana.
Right. A lot of a carriage like this you would find in Louisiana, or I've
Or
seen
New York. There's some in New York.
St. Louis. These are mostly for taking people on tours of a city. But good observation. Resistance, right? This is the force that moves in opposition of the flow of electric current, right? if we were to say voltage is a water pipe, right? And current is the water flowing through the pipe. Resistance would be anything that's restricting that flow of water or electricity, right? So if you got a pipe, right? And you got a hose, right? Everybody's played with the hose in the summer. It just kind of flows out, right? The water flows out. And that's really good for filling up the little swimming pool, right? Or taking a drink out of it, right? But if you wanted to have, squirt your brother, squirt your cousin, squirt your friend, right? You'd put your thumb down on the top of that hose, right? You got some resistance going, right? You're restricting that flow of water. Resistance restricts the flow of current. All right. Just just like this, we're restricting, right? All right. Who haven't I called on? Jimmy, would you read this slide, please?
Okay. The measure of the strength of an electric current.
And that is voltage, right? You can measure voltage with several different tools, right? You take a 1.5 battery. You can use it to light up a no. You can use it to light up a light bulb. You can use the power. Voltage can come through an electrical socket, right? So a volt, right? That's used to measure voltage, and that's represented by the SI unit V, right? Your household lights. Yes, Jimmy.
I want to throw something in there. Did
You want
you
to
know
throw
your
something
wall
in there?
sockets? Did you know your wall sockets can throw out 120 volts?
Yep. That's the Isn't that the standard voltage for most places in the U.S., most houses and whatnot? That 120 volts.
Yep. Then you got 220. Not sure if y'all heard about that, but that's mostly used for welding.
Well, yes, and anything that requires, say, more power, right? More voltage, right? Is we got our household light, right? 120 volts, TV. You just plug it into wall, 120 volts. Some ovens, some refrigerators, dryers, air conditioners, welding units would come in at 220 volts. Jimmy, I'm going to ask you this. Do you use the same type of plug for 220 or 120 volts, for 210 or for 220 or 110? Do you use the
No.
same type of plug?
Looks a little bit different.
Looks a little different.
You got some are sideway prongs. Then the ones we plug in every day are straight prongs or 3-prong outlets.
Okay, so I'm going to show you this real quick. That can be a 220.
That's called a dryer cord.
That's a dryer cord. All right, and we've also seen. Have you seen something that looks like this?
I have.
Okay.
My grandfather has a bunch of tools that use that type of plug-in.
A window unit will take that kind of plug.
Okay. Naraya, Jashawn, Jasper, have you ever seen anything like that? Have you ever
Yes, I have.
you haven't helped somebody move a dryer in and looked at that?
You gotta unplug that from the back of it. Yeah.
Yep. And it's just the fact that the appliance needs more power, and you need to have more ability to deliver power. Okay. But that was very good observation there, Jimmy. I appreciate that. And Dimitri. I've used 220 volts a lot of times because I've had to use air compressors and generators. But we won't get into that. All right, work. Naraya, can you read this slide for me, please?
The transfer of energy by a force acting on an object causing it to be displaced.
Awesome. Okay. So we got to work. Work is transfer of energy, trying to make something, to display something. Hey, we have a puppy. Okay. Welcome, puppy. So
Let's get down.
anything that's in a change of position or displacement is an example of work, right? Dragging a box, pulling a box. Your car breaks down and you need to get a tow truck, right? That's work, right?
Right. Mm-hmm.
Change in speed or direction, right? Soccer ball. In a soccer match, right? You kick the ball and changes speed, right? The ball can go from a standstill to high. Jimmy, yes, Dimitri, did you have a question or a comment?
No, I was trying to my mic got unmuted, so I was raising my hand to go on my mouse.
All right. Jimmy, can you pull up your camera, please? I know it's fuzzy. It's all good. Okay. Baseball, right? You hit the hitter hits the ball, right? Goes for a home run. He's doing work because he's changing the speed and, in this case, direction.
Also, he's changing the velocity of the ball, and he's also accelerating the ball.
Right. So a baseball might go in from the pitcher to the batter at, say, 95 miles an hour.
That's a fastball.
That's fastball. The batter hits it, right? And it'll go back out toward the outfield wall at, say, 105 miles an hour.
It changed velocity and it accelerated.
So also, if something changes size or shape, right? A compressed spring does work when released. Does work on a ball, right? Because you're changing the size of the spring, right? If you're making something out of putty or clay, right? You're doing work because you're changing the shape.
Also, may I say something?
Yes, go ahead, Dimitri.
Vegetables are basically kind of this too, because like if you're cooking, you cut it in the smaller pieces, but it comes in a bigger piece.
Right. You're using work to chop a cucumber up, right? Or a carrot up, right? Or a potato.
Yeah.
Right? Yeah, there you go. All right, so Any questions about any of the vocabulary that we just covered?
No.
No,
Go ahead, Dimitri.
but I have something to say. I'm sorry if I keep interrupting, but I met this. But also, I'm trying to correct myself. All food is like that. All food you can cut it or you can make is like that.
Yep, exactly. All food. Jasper, you had a question there, buddy?
My computer about to die.
Do you have a charger?
No, I know outlets in this room, and my mom's in the other room, so I can't go in there.
Okay. Just go on as long as you can and join back up if you're able to get a charger, okay?
All right.
All right. Doing a little calculations, right? Voltage, right? This is a let me share another screen here with you. All right. That's not what I wanted to do. In biggin and biggin and biggin. All right. Ohm's law. All right. Named after the George Ohm. Voltage is V. Resistance is R. That's measured in ohms. Current is represented by I. And you're going to ask, well, Mr. Campbell, why is it not C? Because C is the first part of current, right? Because it was a French person who put this together and they used their French symbols. Go figure, right? So if we're wanting to find voltage, and we know current and resistance, we multiply current by the resistance and get voltage. Voltage equals current times resistance. If we know voltage, if we wanted to know the current, but we know voltage and resistance, we divide voltage by resistance, V divided by R. And if we want to find resistance, but we know voltage and current, divide voltage by current. Does that make sense? And this is going to be, you all have access to this sheet. Okay. Do we have any questions about our Ohm's law formula? No? Okay.
I just want to put something out there, not as a question, but I can read French stuff.
You can read French. Okay. Awesome. Then Mr. Dimitri, I'm going to slide.
But warning, it has been a while, so if I would say something wrong, it's been a while.
It has been a minute, right?
Last time I studied French writing and read it was when I was 10. I'm 15 now.
All right. Would you be able to read that because this is why it's French, right? This is why I is current and not C. Any chance that you could read this? I read it as intensity du courant, which I'm sure is wrong. Dimitri, can you help me out on that?
1 minute. The do part you got is correct. I haven't heard the first one. I haven't even studied the first word, but the other one is pronounced courant. Courant. It's like that, but you're supposed to say it in like a French accent. That's
Okay.
how they do that.
All right. And as you can see, the 3 ways to express Ohm's law. We just covered this with the other sheet.
Onto soif, super fry.
All right. Everybody, do me a favor, everybody. If you can pull up, it should be a worksheet that in chat will look like this. I want y'all to work together and solve some of these problems. Okay? So we will do the first one together, right? So we know current, we know voltage. We want to find resistance, right? So we know current.
That one?
Yeah, so we would use this one down here. Our formula should be R.
I found it.
Found it? Okay. We're going to do this one together. R. No, I don't want to do it that way. Okay. R. No, right here it is. R equals volts divided by current, right? So 180 V divided by 60 I. Hey, Naraya, welcome back.
My computer, I accidentally pressed the X up there. I was trying to move it over.
And you accidentally hit the exit button.
Yeah.
Don't worry, we all done that before.
All done it. It won't be the first time this week, and it ain't. And I doubt it's going to be the last. All right. So with our calculation, right? 180 divided by 60. 3. Yes, go ahead. 3 and resistance is measured in ohms, right? So 3, it's spelled OHMS. Do you see how that works? All right. Go ahead and see if you can do on your sheet, or if you just tell me what to write. I'm easy. You can collaborate, you can talk to each other, but let's see if we can't do problems 2, 3, 4, and 5 together. Okay? So let's first of all, we would want to figure out the formula. What formula are we using? Okay, so they tell us, they give us resistance, they give us volts. They want us to find current. So what would, if we're looking at our formula sheet here, right? They give us resistance, they give us volts. We want to find current. They give us volts, they give us resistance.
It's volts divided by resistance, right? Or subtracted?
I equals, so this one, is it this one?
Yes.
Okay.
But I don't know if the slash means divide or subtract.
Slash is divide, star is multiplication.
Got it.
So, all right, so we just fill in our, now we just fill in our formula, right? 48 volts. What am I putting for R? What am I putting for R, everybody?
You're putting 24 ohms.
24 ohms. Somebody want to give me some math on that? Somebody want to do that division?
I'll It's 2.
I'm sorry, say it again, Dimitri.
It's 2.
2. All right, and what are we measuring current in?
Amps.
Okay, measured volts. So 2 amps, right? All right, Deshaun, you want to try this one here? You want to try number 3 for me? What they give us voltage, they give us resistance. We want to find current. All right, so they give us they give us voltage, they give us resistance. We want to find current. So which one of these would we use? Which of our formulas would we use there, Deshaun? Deshaun, what are we thinking? Which formula would we be using?
What you say?
Okay, so let's take a look at problem number 3.
Okay, let me go.
They give us voltage.
Mm-hmm.
They give us resistance. They want us to find current. Okay, so they give us voltage and resistance, right?
Right.
So which one of our three formulas, 1, 2, or 3, are we using here?
I think
We're
2.
using 2, okay. Right, because they give us voltage, they give us resistance, right? So
Mm-hmm.
then we get how much? What's the voltage that they give us?
270.
270 V.
Mm-hmm.
Looks like,
And then the next number is 9.
right. And what is our resistance?
Resistance 9.
9. Oh, right. Jashawn, would you pull up a calculator and give me that?
I already did the math, but I'll let Tristan do it.
Thank you, Dimitri. I appreciate that.
I often say he gonna do it. He already got it up. And then I just pulled out my phone for the calculator.
I'm sorry, it's just math's one of my favorites.
Math is mine too.
You like math?
Yes, I love math.
Me too.
A lot of math and
Math and
I hate
science
math.
are tough too.
a lot of
I
math.
hate math.
You like math, Naraya?
Wait, is that
She
divide or
hates
that times?
She said she hates math.
You
Which
hate
it's
math,
scary.
Naraya? All
Math
right,
is
cool.
hard for some people.
I'm not good at math.
All right, so
Okay,
270
math
divided
ain't
by
for
9.
everyone.
You said divide?
Yeah. So what are we putting in here? And so we got. I'll just pull up my little calculator here. Tell me what I'm putting in.
270.
270.
Mm-hmm.
Whoops.
And did you say we dividing?
Yep. Slash is dividing.
Divided by 9, it is 30.
30. And what's our unit for current?
R? What's it? B.
It's amps.
Yeah.
So I don't know if you seriously, if you can't see the screen, just let me know, okay?
Okay.
Because I can play with magnification. I know y'all's Chromebooks are small.
Bring me a good cover.
All right, Jimmy. Let's do. Can you do number 4 for me, please?
I will.
All right. Come up on fuzzy mic on fuzzy cam. All right. So what do they give us? They give us R, right?
Yeah, that amps.
And they give us I.
Mm-hmm.
They want us to find volts, right?
Yes.
So
Right here.
which of our formulas are we using?
R and I. Miss Mayla.
So this one, our first formula.
Yeah.
Okay. So let's put our numbers in, right?
Mm-hmm.
How many I's do we have? What is our I over here?
4
4
amps.
amps, right?
61 ohms.
And what are we doing with them? We're multiplying, dividing,
I would think multiplying or
multiplying. And you said 61 ohms, right?
Uh-huh.
All right. So tell me what I'm putting in my calculator here, please.
4 plus 61.
4 plus 61?
No.
Divided by.
Divided by.
Are we sure it's divided by? Because that's multiple. I thought this
Oh,
one.
that's time.
Multiply. Times.
It's multiple.
Okay, we got times. Okay, 4 times 61, right?
Uh-huh.
Mm-hmm.
And what is voltage measured in? What is voltage measured in?
Volts.
Volts. Okay. All right, so Mariah, I'm gonna pick on you for this one.
Okay.
All right, so they say they give us resistance of 5 ohms, and the current is 2 amps. They want us to find voltage.
Mr. Bruce, that's 0.5. You said 5.
What?
That's
Oh,
0.5.
0.5. You're right. Okay. It's resistance 0.5 ohms. And they want
You
us
made
to
a math mistake. You almost made a mistake.
I almost made a mistake. I'm glad I have y'all watching out for me. So if they have given us resistance
Mm-hmm.
and they have given us current, we want to find voltage. Which formula are we using? So they give us I, they've given us R. We want to find V. Which of our 3 little formulas here are we using?
1?
Formula 1, right. Voltage is equal to current times resistance. So if we we plug in our numbers, right?
Mm-hmm.
2 amps. I'm just plugging in numbers here, right?
Mm-hmm.
So that's multiplication, and 0.5. Oh,
That's 1. That's 1.
okay. So 2 times 0.5, right?
Mm-hmm.
1. And what's our measurement? Starts with a V.
Volts.
Volt. Okay. All right. Well, we took a little bit more time on the discussion than I thought, so I'm going to not worry about the rest of this.
Mm-hmm.
But we do have a celebration of knowledge that I think we can knock out here real quick.
I already did all the others.
Oh, you already did all the others. Awesome.
I did 8 is 9. 9 is 26.
Don't tell me. Go ahead, Dimitri. Go ahead and make a copy of that and send that one to me. Okay.
All right, I will.
All right. So, celebration of knowledge. right? This is our last thing that we got to do for our lesson, right?
Mm-hmm.
Which analogy best describes voltage?
Volts.
So the analogy that I used was water through a pipe. Do you remember that? Mentioned it.
Yes, of water moving through a pipe. Yeah, I remember.
All right, so we're going to. Everybody agree with water through a pipe? All right. What's the best analogy of amperage? So if water is going through a pipe, right?
I think it's A.
So okay, well let me ask you this. We have two hoses, right? We have an itty bitty hose,
Oh,
right?
that's the thumb thing. Yes, the hose thing. Yep.
And a big hose, right?
Mm-hmm.
Small and large, right?
So is it
Which
the
which
diameter?
hose is going to have more water pass through it?
The bigger one.
The bigger one. So are we saying diameter maybe?
Diameter. Yeah.
Everybody agree with that? Okay.
I'm gonna mute so I can let other people tell the answer.
Which best describes analogy, right? Or which analogy best describes resistance? So we have a pipe, right? And we have the pipe gets crushed a bit, right? Or there is a we're using the water to turn a turbine or a windmill, right? A water
It's A.
mill. So which anthology best describes resistance?
It's A.
It's A. Everybody agree with a turbine or a mill inserted into the flow of a water?
Yeah.
Okay. The current in a circuit is halved. What happens to the resistance? So current is halved, right? I don't know. So if we have, well, let's do a sample one real quick, right? If our original current is 4, right? And say resistance is 2, right? We have the current in the circuit is half. So current is I, right? And then we go from so we are actually
Current will double.
current level is going to stay the same.
No, it's gonna it's gonna double.
That's going to double. The resistance is going to double. Everybody agree with that one? All right. Last question. Flashlight has 4 1.5 volt batteries. Bulbs have a resistance of 2.4 ohms. What's the amperage of the circuit, right? So we have 4 times 1.5, right? That's our voltage. They give us 2.4 ohms, right? Resistance. What is our formula that we need? We want to find amperage, right? That is the current, right? Which of our formulas are we using? No, I can't. If you said something, I couldn't hear you.
No, I was talking to him.
Okay. We're using B. So
Sorry, he's using the printer, and the printer's in my room.
so I equals volt divided by R, right?
Yes.
Okay. And somebody said it's B, so let's take a look at that, right? So first of all, we have to figure out how many voltages completely going through here, right?
Yep. I'm paying.
Somebody give me a calculator for 1.5 times 4.
I got it. 1.5 times 4.
Yep.
That's 6.
6 and divided by resistance 2.4.
I got it.
So 6 divided by 2.4.
That's 2.5.
2.5. All right. So we had everybody agree with 2.5. All right. It didn't go through. Highlight green. All right. And according to my answer key, we all got 100%.
Nice.
Hey, we got 100%. Everybody, woohoo! Give yourself a big hand. Or everybody give a round of applause. All right.
I'm
Thank you for
clapping very gently.
coming to my class and enjoy.